Lovely. So obviously, Ali, great to have you here.
Thank you
if
very
we
much.
can start off by maybe introducing your background to the audience, how you ended up in the crazy world that is IoT and technology.
Yes, of course. So I'm Ali Rohafza. I'm from Altered Carbon. We've been working for the past 3 to 4 years on building graphene sensors. We started off working on internships at UWE and then got into the Bristol Robotics Laboratory, which was an amazing place. Learned a lot from them, and then that's where we started our own company in a way and decided to kind of make a change in how sensors were used.
Yeah, brilliant. So kind of leads nicely on to the next question. So what was the journey of finding Altered Carbon down to the point of how did you come up with the name and things like that, and yeah, what actually kick-started it all?
Well, basically, we had a company before this, and it was in that company we built development boards for other people's gas sensors. And so by doing that, we learned a lot about how gas sensors worked and what we liked and disliked about them. And so they had loads of problems where they were trying to look at very specific things and trying to define those specific things, where we started to look at the problem as a bigger picture scenario. So we started to look at it as, well, instead of knowing what like carbon monoxide is, we were like, actually, what does a signature of, like a digital signature of a scent look like? What about you? Like, what scent are you releasing, like pheromones? And how does that look like? And can we build triggers and use machine learning AI to actually create indications of problems or scenarios that you need to pay attention to? So basically, we worked on that for a few years. It was an actual accident that we came up with the sensors in a way, which was amazing. We were trying to build graphene batteries and then kind of didn't work on graphene batteries and then realized that the graphene batteries we built were actually sensors. So in our labs, someone was spraying this PCB cleaner, which is basically a chemical, and then we saw indications of it working, and then we started developing into that. And then we worked with loads of massive partners like NPL, National Physical Laboratory, which are massive, and loads of other things like the National Biofilm Institute to build this sensor out and to do external testing and validate what we talk about.
Amazing. So you basically stumbled across it.
Yes, in short.
Yeah, I mean, some of the best ideas in the world are
exactly
accidents, right? Yeah. So you're now one of the leading companies in the world with commercially viable graphene. So what I'm interested in, I'm sure what the listeners would be interested to know is why the sudden shift of graphene in sensors and what's typically limited it before.
So one of the biggest limitations was actually producing enough graphene. So you can use it in smaller batches. So if you need to build test runs or stuff like that, it's fine. But when you go to commercial levels where you need larger amounts, like they were trying to put graphene into cement to make it stronger or into tires, they work for certain scenarios where it's expensive products, but they don't in certain scenarios where you need more cost-effective solutions. So graphene has real benefits all across the board, but using a lot of it means you have to build these giant reactors that take a lot of money, a lot of power, and so they couldn't do it before. With our system, we use such tiny amounts of graphene and bond it to other materials to detect. So we build these receptors, and these are what our array is built out of. And each one of them take the tiniest amount of graphene in an ink format that we deposit. So that means we can actually deploy this on a mass scale where other solutions, if they have to use a lot of graphene, won't be able to as easily, or their solution would just be too expensive. What our vision is to make this solution available to everyone, not just some people.
Yeah, which seems to be going really well. And I think we're in a world, right, if you can use less is more.
Yes, exactly.
Effectively. And I think that's, well, especially in the crisis we find ourselves at the moment with energy.
Yeah, definitely.
It's just madness. So
we're looking at it because our main part of our chemistry is all green chemistry. The only part that we're hoping we're actually trying to do research projects in is hopefully looking for a way to change even the PCB layer that we use into something where it's more eco-friendly and it could basically biodegrade in the future. So then our sensors could be fully basically compostable. So you could use it for a period of time, but then actually dispose of it really well, because electronics have that really big problem of they will go into landfills and stuff like that, and it's really hard to process that. So we're trying to find solutions even around that. We know our chemistry is fine, but the other parts of a board is what we're working on at the moment.
So you've got quite a lot of technologies across different areas. What would be good if you could explain is the key parts of the technology involved in the digitalisation of scent.
So the key parts of that is, so the sensor array itself, so it's multiple elements, each different, that get different, basically, if you imagine each one is a different signal that bonds to different gases, exactly like how your nose works. Imagine how when you were a child and you learned what the smell of popcorn is, and someone had to tell you what that is and then repeatedly tell you what that is until you learnt it. So we use machine learning and AI for that part of the learning part. And then we use the sensors to take in signals and then translate that in a way. So those are the two most important parts of what we do. And then we build like a scent library, that's what we call it. And then through that, we build scenarios where we say, how close is it to this scenario? So is it a match of 80%, 90, or what is the match between this product and this? Or how close are you to, maybe it goes, in a doctor's surgery, it will go, well, how close is it for you to have this illness? Potentially you want to go and get these tests done. So it may not exactly tell you, but we're like an indication method.
Yeah, good. And obviously you touched on the sense. So I know off camera before you mentioned something called canine sense. So it would be good to touch on that. And I know that it can be used for different things, healthcare, diseases, poison, whatever it might be. So what areas you typically see in that technology being deployed in, and what areas are having the most success from that?
Basically, this was one of our issues at the start, actually. There's so many areas this technology can go into. Focusing on one was the most important thing. So we actually tried to go into medical at the start, but of course, when you're an early company startup, it's also very difficult. So what we focused on actually was food waste. This is one of our big interest areas. And basically, there's a lot of food waste that happens. And for us to help manage resources better is one of our main focuses. So if you could stop basically food being thrown away before it even gets to the stores is a really important factor. For us, if we can use our sensors to tell when food is ripening or going off, so basically becoming to the stage where it's going off, and telling people earlier that this may go off in a week or it's ripened. So it comes off, bananas come off a shipping container and we know they've already started ripening. So instead of sending that to the warehouse, you go send this batch to the store first, and then keep the other ones that haven't ripened in the storehouse. So at the moment, they don't do that. They just send everything into a warehouse. Whatever comes in first goes out first, and whatever's at the back gets left behind. So then you lose a lot of product through that. So instead, if you could just organize it well and go, well, no, the cargo at the back actually needs to go out first because that's the closest one to ripening. Or this product, if it got sold, it only has 4 days left, just sell it for a lower price, it's fine, but you will still maintain that product. So we hopefully get rid of sell-by dates or use-by dates in the future, make them more efficient.
I mean, again, we keep touching on it, but the world we find ourselves in at the moment, that's going to be so key because there is a lot of wastage.
There's enough resources for everyone. It's just how we manage them isn't right yet. And it's a learning process, so it's never going to get better instantly. It's new technologies that will come up that will even help our technology to benefit that scenario and make it better through that process.
Good. You touched on a couple of things there. I mean, you mentioned that the difficulties of going into, there were so many sectors. There's different challenges about different things. I'm keen to know what your biggest challenge has been, how you've overcome it, and how you're going to avoid it next time.
So one of the biggest challenges is actually, it was actually finding how to make the sensors stably in a really reliable manner, because the areas we go into, you can't have as much variation and stuff like that. So that's a really big challenge in sensors altogether. Everyone has the same problem. So everyone has problems with humidity, everyone has problems with different scenarios and like false information, kind of some gases look exactly like others, so you may get triggered by certain things. Like my home carbon monoxide alarm right outside my bathroom, if you have a shower and walk straight out and leave it open, the mist from it actually sets it off. But it's like, that's a false alarm. So working on how to solve those problems is one of the biggest challenges. And I don't even know how you would speed it up in another scenario. The learning we've had is work with partners. So we fund 3 PhDs in the university. We work with multiple departments. We've worked with multiple other labs around the world that all we've worked with and kind of set out our problem, and they've helped us solve different areas of it and get further and further. And it's all about the collaboration we've had and the BRL and NPL that have helped us really understand what the way to solve it is. It's like never. I don't know how you would speed it up, but it's just that collaboration really helped us progress.
I think something I'm learning from you is relatability in a lot of different aspects of life.
Yeah.
Don't be afraid to ask for help.
Yeah.
Learn.
Don't be afraid to be wrong as well. I feel the worst thing is someone will say no, it's this way, and then you'll learn how to do it better. But if you're afraid to be wrong, then you won't ask the right questions, then you won't get to the right answer. So that's what we've learned throughout the process. Is we didn't know a lot about what we were doing, but we were willing to learn everything, and now we work with some of the best people, and that's where we've gone into.
And you're heading in the right direction, which I suppose leads lovely on to ask, what is the next step? What's going on with Altered Carbon now? Let's say what you're doing in the next 3 to 5 years.
So we've just secured our funding round, and an Innovate grant, which will help us progress. And we're now just working with some clients on early indicators for sensors in potentially being used in refrigeration to detect food spoilage, different areas like that. So at the moment, we're trying to develop as many co-development contracts as we can, and basically build up these partners that we're working with that then will license our technology. Imagine in about 5 years, we would love this technology to be in scenarios where it can't be done right now with majority of sensors because they're not cost effective enough. But because our sensors are printable, we want these sensors to be everywhere. So imagine walking into a doctor's surgery or hospital. If you had these sensors on every single wall, like every couple of meters or something, you could potentially indicate if someone walked in with an illness or COVID, and track them throughout where they went, who they came in contact potentially with. And it's this visualization of scent that we could do of, okay, this happened, this happened, this happened. And you could create indications and also alert people to scenarios where certain dogs can detect cancer or diabetes. Potentially, this is what we hope to do in the future. So it's indications of, oh, you could have this, do this test, is one of the most valuable things I think will be out there. And you could do it with our sensor because it's cost effective and you can deploy it en masse.
It's a big statement, but I'm going to ask it. Do you see potentially Altered Carbon having a direct impact on saving lives, by the sounds of it?
It's a hard one to say. We hope to, 100%. It's a really difficult one to say because you don't ever know where the technology will go. But yes, even in the food area, by just us helping reduce food waste, we'll be impacting people's lives because there'll be more food for other people. Even in healthcare, if we can indicate, it's still early research. This is why it's hard to talk about, and some of it's private. But
of course.
Yes, we hope to do that in the future. This is one of our main focuses.
Yeah, amazing. Now, I'm going to ask you a question, put you on the spot a little bit, but I'm keen to learn a little bit more about Ali. So, with all these sectors and all the opportunities that are out there for Altered Carbon and the technology, is there one that particularly interests you, whether it's a little bit easier or a little bit more difficult? Is there a certain area that you want to see this technology in?
This is a difficult one. So, one of my really big interests, and this is why I was always interested in sensors, is actually, funny enough, it's like Alzheimer's.
Okay.
So Alzheimer's is a brain degenerative disease, and one of the main indicators that happens around 10 years before is the loss of the sense of smell. So you lose that sense of smell, and that's directly linked to your memory. And so that's why some people that get it can't access certain memories. That's why even visually they may forget something or see some things or see themselves and not recognize themselves. And they're linked from that to their memory. So my real thing personally was always that if we created some sort of sensor, and I don't know if our one will do it, but I was like, if we put this idea out and someone else even finishes it, I'm happy with that. But if we manage to do this, and there could be a link that we find between how the loss of sense of smell and that part of the brain works, then maybe we could build sensors like how they've built hearing aids to connect the two, and then hopefully do that. My grandfather got Alzheimer's, and remembering the last bits of his life is one of the difficult parts of, like, he lost basically the memory parts of like who even was his wife, sort of thing, and it was a really hard sort of scenario. So I've always had that image in my head, and it's different for different people in my company, but that was one of my main focus areas that I was always interested. That's why I'm not as interested in looking at just a single gas, but just looking at the image of a scenario, like what is the complex mixture of that scenario,
Yeah.
and what we could do to sense it and hopefully then implement it into a scenario in the future. But that's really future.
Yeah, of
based,
course. Yeah. I mean, well, thank you for the insight
Yeah.
into obviously life experiences and you. I think that's one thing that I've learned since doing the podcast is a lot of the best stuff comes from life experiences and a personal drive.
Yep.
And who knows, if you've got that personal drive, you might get there.
It helps.
So fingers crossed.
Yeah.
Best of luck.
And you have to try. Like,
Yeah, exactly. We've touched on it. You learn
have
from
to
your
try,
mistakes.
and if you at least you believe in the idea enough, you have to actually try and forward it.
Yeah.
And if it does, then great.
Yeah, amazing. Right, Ali, what we're going to do now on the just before we wrap up is some quick fire questions. As we've already discussed, this is new to you and new to me. So
Yes.
let's see how this goes. Right. So the first one is describe your business in 3 words.
Chemical visibility.
That's 2, but we'll roll with it. Favorite technology use case?
Food waste.
Apple or Android?
Apple.
Biggest achievement in your career? The fact that you got to think about it tells me you've got lots of achievements, which is good.
Yeah. No. So one of my favourite achievements is actually speak in front of students now.
Yeah.
So I get to talk in front of them, tell them about what our business is, and tell them about what difficulties I've had, like dyslexia, ADHD, and how I've managed to progress with it.
Well, you're inspiring people, which I suppose is a very big achievement, to be fair. Who is your biggest inspiration and why?
Ooh, it's hard. So my stepdad actually,
Okay.
he's a really amazing person, and he actually taught me patience and how to be calm and how to deal with certain scenarios really well, which was amazing.
Yeah, fantastic. One word to summarise the technology landscape this year.
Messy and not enough resources.
Yeah, messy's a great word. What advice would you give to your younger self?
Oh, try more things and don't be afraid to ask questions sooner.
That links back to the start. That's good.
Yeah.
What is one quote you live by?
Oh. Don't fear being wrong.
Yeah, good. Thoughts on the metaverse?
Ooh, it's interesting. Has loads of good use cases. Probably 90% or 95% of the stuff could fail, but 5% of them will succeed.
Yeah, and that 5% will be really good, I think.
Yes.
And the last and not least, driverless cars. Are you a yes or a no?
Yes, actually.
Yeah?
Yeah.
You ever been in one?
Yes, I have. So we've done projects with UE. Well, they've done projects with driverless cars, and we've worked with them, and it's been really interesting. So I'm yes for them, definitely.
Lovely stuff. To wrap up, I suppose we have got something ticking away in the background, but it'd be good if you can give the audience a little look into where they can find you, websites, social medias, that sort of stuff.
So we're on, our website is altered-carbon.com, and our Twitter is AC Sensors.
Thank you. It's been a pleasure to
Thank you
have
very
you, and I'm really excited about where you guys can go. And fingers crossed the Outsiders thing pays
Thank you
off.
very much.
So thank you.